So what I'm going to do in this video, I'm going to take a couple of past paper questions relating to the polynomials and functions topic. I'm going to show you them and I'm going to work them through. Now I've got 3 of them here that I'm going to do. I've got 2 non-calculator questions and a calculator question. This is to give you an idea of the general formatting, the general style and the standard of the questions that could come in, because they always tend to be roughly the same sort of stuff. So the question I'm going to show you are these 3 here. So the first one is looking at an expression and showing something's a factor and then factorising it. The second one brings in the idea of inverse functions and how we work with them. And the third one is looking at suitable domains of functions, composite functions and certain formats that we need to put things in, and looking at domains as well. So here we go. So the first one, show x plus 3 is a factor of that, and then hence factorise the expression fully. Now, when we were showing something as a factor, there were 2 ways that I told you we can really approach it. The first is to look at it from a synthetic division point of view. The second is to look at it in terms of a substitution. So I'm very quickly going to show you both for that and then how to approach the factorising part there. So first one, showing that x plus 3 is a factor there. If you want to use substitution, first start by setting x plus 3 equal to 0 and then changing it to x equals minus 3. Now if this is a factor of this, if we substitute an x equal to minus 3 into this expression, we should get a solution as 0. So you can imagine we do minus 3 cubed, take away 3 times negative 3 squared, take away 10 times negative 3 plus 24. So we work each of these through, so negative 3 cubed, well negative 3 squared is 9, times by negative 3 again is negative 27. Take away, well 3 times negative 3 squared, negative 3 squared is 9, times by 3 is 27. So then take away 27, minus 10 times negative 3 becomes plus 30, and then plus 24 at the end. So negative 27 take away 27 is negative 54. 30 plus 24 is 54, so I've got negative 54 plus 54, that equals 0. At this point we have to explain what we've done. You can't just leave it. So at this point we would say, therefore, x plus 3 is a factor of the expression, so of x cubed, take away 3x squared minus 10x plus 24. So if we were to do it this way, we express our final part like this. Now if we were to use synthetic division, we would start off the same sort of way. So we would start with this key step here. The x plus 3 is 0, so x is negative 3. We would just lay out our working slightly different. So this is where we use our nested form for it, and we would put the coefficients along the top. So our coefficients here are 1, negative 3, negative 10, and then a 24. And then we use our nested form to do the synthetic division, and if it's a factor, this would be equal to 0. So 1 goes down there to become 1, becomes negative 3, negative 6, goes up there and becomes 18, that becomes 8, goes up here and becomes negative 24, which then goes down and equals 0. So at this point we then have to state this. We can't just leave it again like this. What we have to say is, therefore, since the remainder is 0, x plus 3 is a factor of the expression of x cubed minus 3x squared minus 10x plus 24. Now this is a key thing. I've seen too many marks lost in the past in previous exams and previous past papers where people haven't expressed that final statement. Please make sure you do that. You don't want to cost yourself a silly mark at this point. We then want to factorise it fully. Now factorising it, I always find this bit the best, because here's the coefficients of the first factorised set of terms there. Because at this point what I can say is, therefore, x cubed minus 3x squared minus 10x plus 24 can be written as the x plus 3, because we know that's a factor, and then these ones here give you the coefficients of x squared, x, and the constant at the end, x squared minus 6x plus 8. We then want to look at this part and see if we can factorise this from there. Well, to check it, you could do your b squared minus 4ac. So negative 6 squared is 36. Take away 4 times 1 times 8. So 4 8s are 32. So 36 take away 32 is 4. So this can be factorised. So first bracket is going to stay the same. Our first bracket is still going to be the x plus 3. What we're then going to do is have to factorise this. Well, this can be factorised to x minus 2, x minus 4. And that's us fully factorised that full expression. So we've done the parts it wants us. First, we've shown that it's a factor of that. And the second is we've factorised the full expression. Now, for the shown it's a factor, it doesn't matter whether you do it this way or this way, as long as you show it properly. Pick the method which is best for you and which you just click with a little bit better. Second question, so a function there, define a set of real numbers. First I want to get the inverse, then I want to write down an expression for g of g minus 1, so g of the inverse. Remember, for the inverse, you always start the same way. So we start by changing it from g of x to y equals 6 minus 2x. We then swap the x and the y around, so we write x equals 6, take away 2y, and then change this around so the subject of the formula is y, so it becomes y equals again. So we start, shift the 2y over there and shift the x there. So I get 2y equals 6, take away x, divide it by 2, and I get y equals 6 minus x all over 2. Now this is the key stage. Don't leave it like this. You have to now say it's the inverse. So you have to, at this stage, go back and substitute in g minus 1 for the y. So you have to write g to the negative 1 of x, so the inverse function equals 6 minus x over 2. If you don't do that, you will cost yourself that final mark. And then the second one, well, this one's actually fairly straightforward and easy. G of g minus 1 of x, we can write down the expression for that very quickly. It's x. Any function taken as a composite of its inverse always gives you x as a final answer. I'll quickly show you that. You get 6 minus 2x for the g, so it'd be 6 minus 2 times 6 minus x over 2. Substitute it all together. You get 6 minus, well, 2 times that. They cancel, and it's negative, so it's 6 minus 6 plus x, which equals x. Always remember that. That's a nice quick way of doing it. Any function composite with its inverse always gives you x. So those were two non-calculator questions. A typical calculator question is something like this. So I've got two functions, f and a g, and I've got three parts to this question. First thing I want to do is find an expression for the composite. Then I want to express it in a certain form. Then if I've got another function here, given by this, what values of x cannot be in the domain of h. So let's break this down and have a go at it all together. So composite, f of g of x. Well, we've covered composite functions before. We know how to approach that. We know for f of g, it's going to be f of whatever the function g is, 1 plus x, 3 minus x, plus 2. So it's f of that. So wherever there's an x for f, we substitute that in. So in this case, it would be 10 plus all of this. So 10 plus 1 plus x, 3 minus x, plus 2. Now it's a case of simplifying it out. Now these brackets can be multiplied, constants and like terms can go together, and we're able to simplify it. So 10 plus 2 is 12, plus, well, 1 times 3 is 3, it's minus x plus 3x, so we get plus 2x, it's then minus x squared, and then simplify it again, gives you 15 plus 2x minus x squared. So that there's our first part. We've got an expression. Our second part, part B, is taking this and turning it into this form. So we want f of g of x to be in that form. So we know f of g of x is 15 plus 2x minus x squared. Well, remember, put x squared as the first term. So in this case, it would be minus x squared plus 2x plus 15. Now remember, when we did this, you focus on this part. Leave the constant, take it through, and it will simplify itself at the end. First thing you do is you take the coefficient of x squared as a factor of these two terms. So we're going to get negative 1, although you could just leave the 1 off, bracket x squared minus 2x plus 15. You then look at this stage and you have to write it using the x plus or minus something. So in this case, is going to be x minus 1 squared, because when I multiply that out, I'm going to get the minus 2x. But remember, we've now got a correction factor, because when we multiply this out, we're going to end up with an extra plus 1, so I have to do the minus 1 to correct that. I've then got my plus 15 there. Now what I do is simplify this as much as I can. So multiply out this whole bracket by negative 1, then simplify. So I get negative x minus 1 squared plus 1 plus 15, which gives me negative x minus 1 squared plus 16. That's the answer for part B. Now for part C, h of x is 1 over that. What values can it not be? Well, 1 over that means that h of x equals 1 over 16 take away x minus 1 squared. Now for a value of this to not exist, the only way this can happen is if this bottom line, so your 16 minus x minus 1 squared, equals 0. You can't divide by 0, so if it equals 0 on the bottom, that value cannot exist within the domain. So we have to solve this. So shifting things over, I get x minus 1 squared equals 16. Take the square root of both sides, and I get x minus 1 equals 4 or negative 4. Now remember, when we take the square root, we have to take into account both values, because 4 squared is 16 and negative 4 squared is 16. And I can then solve it for both of these, add 1 to both, so I get x equals 5 or negative 3. So it cannot exist for either of those two values. Neither of those two values can be in the domain of h of x if it is given as this form. So there's 3 examples of the types of past paper question that come up for polynomials and functions. Use these to help you a little bit. Make sure you follow the general steps of working for this type of question, and use it when you're looking at previous past papers again, where there may be this kind of question too.